Hi everyone, my name is Joe Barnard and welcome back to Landing Model Rockets. This is episode 6 and today we're going to drop some cash. We have this bill of materials and all of these design files ready to go and we need to actually make these purchases and get these things shipped. And before we do that, hey Alexa, I was really hurt by what you said in the last episode. You really kind of came at my integrity a little bit and I just wanted you to know that.
I've been thinking about this every day for the last few weeks. It's been driving me crazy. I'm so sorry for what I said, and I hope you can find it in your heart to forgive me, Joe.
Wow. That's really big of you, Alexa.
I still gave all your files to Jeff Bezos, though.
Wait, what? Alright, so there are basically two things we need to do in this video. We have our PCB design files that need to get manufactured by a professional PCB producer, and then we have our BOM, or bill of materials, and those are the parts that we need to order from a warehouse distributor or something like that. We'll start with the PCB manufacturing process, and there are lots of options on the market, so let's take a look at a few. So to get started here, I'm going to search for PCB Manufacturing online. And we'll look at our results here. So we've got PCB Way, 4PCB, Slingshot Assembly, All PCB, JLC PCB, 4PCB and PCB Way again, PCB Cart. We're going to be saying the PCB acronym quite a lot. Once again, that stands for Printed Circuit Board. But let's go ahead and click on the first one. We've got PCB Way here. This is probably a good time for me to mention that most of these manufacturers are going to be just fine for our purposes. They all have different qualities and they all have different strengths. Some of them are really cheap. I know PCBWay is a super cheap place. Advanced Circuits is great if you want to manufacture in the US or if you're in aerospace or defense. There's some like super cheap ones like Dirty PCBs and whatever. There's all sorts of options. But we'll take a look at PCBWay's site here because they have a couple of good tools that we can use. The first thing that we'll look at is called Capabilities, and you'll find this on most PCB sites too. This is basically the page that is going to tell you what you need to do to your design so that PCBWay or whoever you're using can actually build it. This is the tolerances of their machines and things like that. So let's take a look. If I scroll down here, you can see some of the capabilities that they have. So for number of layers, they can do anywhere from 1 to 10 layers of a board. That's fine. Our board has 2. The material that they use, the maximum PCB size is a 0.5 meter by 1.1 meters. That's a large PCB. That's going to be just fine for us. We've got tolerances, board size, board thickness, all of these different things that you can basically spec out in your design to make sure that if you send them your file, it will work. And once again, this is something that just about every PCB manufacturer will use. So if I go back here and look at 4PCB, let's see, they list their capabilities here too, so they may be a little bit different than PCBWay. You've got their total pad size, the material thickness, all of these other, just interesting things that let you design for the manufacturer you're using. Depending on where you get your PCBs manufactured, you might have to submit several different types of design files. These are things like Gerber files or Exelon files or .brd files. These are the files that basically define how big your board is, where all of the cuts go, where you need to etch the traces in. So these are the files that the machine that actually builds the PCB is going to read. Now, I know for a fact, if we scroll down here, Oshpark will actually take the native Eagle files. These are the .brd files that come out when we design the, layout of the board. And as time goes forward, a lot of different places are accepting files like this because it's a little bit easier to just use your native file than it is to generate these Gerber files. If you're not familiar with what a Gerber file is, it has nothing to do with the baby food. We'll actually go over how to generate Gerber files like this. But if you look at the Oshpark website here, it says, let's get started, drag and drop your KiCad, so it works with them too, Eagle or zipped Gerber files here. So these are examples of what type of file these manufacturers usually accept. As a fun side note, I actually have a couple boards that are made by Oshpark here. These are the really early signal development boards. This is when the signal computer was supposed to have a screen and button interface on it. This is when the signal computer was supposed to have an IMU on the TVC mount too. A lot of interesting design choices, but Oshpark is a great way to get started if you're really new to PCB design. They're really friendly to work with, they've got pretty good quality boards, and they're all purple, which is cool too. So moving on here, we have our blip and blop design files right here. These are the .brd and .sch board and schematic files that we built in the last 2 episodes. I'll go ahead and open up the .brd file for blip. So once again, you could submit this file to several manufacturers and actually get the board made, but I generally like to stick with the Gerber files instead of the board files or the KiCad files. So once again, this is just a preference. You can do whatever you want. So before we generate these Gerber files here, I'll once again remind you that I am not an expert. I'm not like professionally trained in any of these things. So if you want like legitimate tutorials, you should click on the link in the description down below. And so to get started here, we're gonna open up something called the CAM processor. That's this little button right up top. It's gonna open up a window that predictably says CAM processor, and we've got a bunch of different options here. This is actually a new interface that I'm not super familiar with, but I'll do my best to actually cover it. Let's focus on this little box right over here. We've got a bunch of different names that might seem foreign to you if you're not into PCB design. And by the way, just as a pause moment here, in the description down below, there is a link to a video about how PCBs actually get manufactured. It walks you through the whole process. It is so cool and fascinating, and it will help you understand these things better. But if you already understand, or if you just don't care, here are the files that we're going to be generating. These are called Gerber files. So we have something called Epsilon. This is going to show the machine where to actually drill. Top copper, that's the top of the board where the copper is going to be etched. Bottom copper, which is predictably the same thing, but on the bottom of the board. We have the profile, that's the outline of the board. That's where the machine is going to cut to actually route around the side of the board. We also have the solder mask top and the solder mask bottom. This is where we're just going to stop the masking of the solder with this material. It's basically what covers the copper etching so that it doesn't short out all of the time. We have solder paste top and solder paste bottom. We actually don't have a whole lot of these because there aren't a ton of surface mount components. Most of the components on the blip board are through hole. And then finally we have our silkscreen top and silkscreen bottom. These are the graphics that we put on these boards, and this is going to help us assemble the board a lot faster and have things make much more sense when it actually gets produced. As a side note here, these are all the settings that showed up by default when I opened my CAM processor, but just in case, you might want to check by clicking Gerber and making sure your output type says Gerber RS274X. There are a couple of different settings that you can select from here. 274 is the one that I like to use, but you can also import different file settings and different sort of profiles. So if I go here to load job file, I can scroll down here and do either recent CAM jobs or local CAM jobs, or even third-party. Eagle comes with a couple that are loaded in. So here's Oshpark from before. That's one of the PCB manufacturers we looked at. If you load Oshpark 2-layer, it's going to have all of these new names that represent fundamentally the same things. We've got our board outline. It looks like we have a top solder mask here. We have the bottom copper layer, bottom silkscreen. They're in slightly different orders, and they represent, slightly different things, but basically these are templates for how different manufacturers would like to have their Gerber files presented. This is all kind of complicated. If you're lost, don't worry. There are lots of tutorials online for this. I'll put a couple in the description down below. We're going to go ahead and load up from our recent CAM jobs, template 2-layer. This one's fine with me. So let's generate these files by clicking Process Job, and then we have to select where these files are actually going to go. So we have the blip blop PCB layout files. I'll create a new folder here called Gerber Files April 2019. And I like to date all of these folders too because the Gerber files aren't easy for you to preview or open on your computer. So I just date when they were created, and that helps me actually during the manufacturing process. So 1, 2, 3, create. Oh, that's just the folder. We'll open the folder and I'll hit open. It's going to process the job now and create all these files. There we go. Job processed successfully, open folder. And if we go into here, we can see all of these different files that were generated specifically for this blip board. So we have the copper bottom, the silkscreen bottom, the solder paste bottom, all of these things. So once again, depending on where you get these PCB files manufactured, usually what you will do is you'll take all of these files here, including the Epsilon or drill files, and then you'll compress them. So I'll say compress 11 items here. I'll name this something like Joey B's Fantastic PCB. PCB, I can't type. PCB, there we go. I cannot type it all today. And then usually that's the step where you can submit these to most board houses or most PCB manufacturers. So that's a pretty basic overview of what Gerber files are and how you generate them for a manufacturing house so that they can build your PCB. This process is probably a little bit different in KiCad or different programs. And again, if you want more details, there are tutorials in the description down below that will be a little bit more in-depth. Now that we have our Gerber files generated, the next step in this process is to get these PCBs actually manufactured by a manufacturing house. And to get a sense for how this works, we'll go to back to our Google search here, and PCBWay actually has a pretty good instant quoting tool. So we'll click on Instant Quote up here and take a look at what comes up. This first section here deals with how many boards you want to get manufactured, how large they are, and if you want to panelize them. If you're not already familiar, you can panelize a board, which means you basically have several boards that are set up in one larger PCB, and this actually makes it easier for the machine to build these boards than it does for the machine to manufacture one of them at a time. Makes things just a little bit more efficient, and this really gets seen when you start manufacturing in super bulk, like tens of thousands of PCBs, things like that. Okay, so we've got our board dimensions here, and we'll start with the blip board. So what are the blip board dimensions? What a great question. I don't know this off the top of my head. It's 57 by 100, excellent. So we'll put in here 57 by 100 millimeters. We're just gonna do one different design, a single piece board, and how many boards we'll make, we'll just do 5 boards. I don't need that many, but it's really cheap to do 5 boards. So this next section here deals with the materials we're going to use for this board. So this is FR4, that's the fiberglass. You probably won't need to change these settings really. The thickness of the board is going to be 1.6 millimeters, that's pretty standard. This is where it starts to get important. So we have the minimum track spacing, the minimum hole size, and a few other constraints here. I'm going to leave these settings the same because I know what these design criteria are. But if you're designing something super small or a really extreme or really far from what a standard PCB might look or be designed like, you start to get into the territory where you need to consider your PCB manufacturer a little bit more heavily in your design process. So once again, that's why this Capabilities tab exists. If you wanted to design a board, let's just try to pull something out of thin air here. I haven't really planned this. Let's say you wanted to design a board that has a tolerance of 0.01 millimeters in the thickness of the board. So you need something for maybe an aerospace or defense or medical solution, and you needed it to be a really tight tolerance of the board. PCBWay could not do that board, at least in their quick turn capability. This is a lot of information here. I hope you don't mind just going all the way into the weeds. Anyway, so we've got our board settings here. I'm just going to leave these as they are. The solder mask is the color of the material that's on the top of the board. So once again, for example, this one has a red solder mask. Signal is a white solder mask. There's a couple versions of Signal that are a black solder mask. You can get any color you want. So I'm going to choose a white solder mask with a black silkscreen on top. That's kind of what I like for most of the BPS boards. Most of these things you won't have to change to. This is our copper thickness on the board. In the last Landing Model Rockets episode, I mentioned this a little bit, but you want to consider the copper thickness of your board. This is especially important if you're sending lots of high current through the board. So my board is spec'd to use 1 ounce of copper, but of course you can go all the way up to like 6 ounces, and that's if you're really carrying a lot of current. We don't really need to deal with these additional options here. These are for fancier sort of boards, and it looks like at the end you could give them some details or just sort of add a personal message in there if you want. And then down here, there are 2 other tabs. So this one is SMD Stencil, and this one is Assembly Service. We're not going to be using the Assembly Service, but the SMD Stencil will be really helpful for the blop board. And if you remember, or if you need a refresher, the blip board is the one that has all of these through-hole components. That's really easy to solder. If you're even if you're good at soldering, but you only have a traditional soldering iron, you're gonna wanna build the blip board. But if you're used to SMD type soldering or really tiny components, you're going to want to get that SMD stencil with this board. And that's going to allow you to squeeze all of this solder paste on top of the board. We'll get into this a little bit later, I think. But for now, we don't need an SMD stencil with the blip board, so I'll go ahead and calculate the cost for this. And it is nothing. These boards cost $5, so that's $1 per board. And of course, if you go up to more boards, you can get them from cheaper. And the most expensive part about this is since it's shipping from China, it's actually $17 for shipping, $5 for the board, so $22 total. Not bad. So this is kind of the process process for getting PCBs manufactured. I'm not trying to endorse any one specific manufacturing house. PCBWay does pretty good work. You can go with Advanced Circuits, you can go with Oshpark, you can go with any PCB company you want. It's going to be something similar to this. After this step, you'd probably submit your Gerber files, and you'd be all set. So that is the PCB manufacturing side of this video. And now we have to deal with getting these components ordered so that we can put them on the PCBs when they arrive. So as with all things, there are a lot of ways that you can go about doing this. Just as an example, I'm looking at the computer now and there's a little button called PCB Quote. And what I'm realizing is this might actually be an easier way to get your printed circuit boards made. There's also something called Design Link, which is sort of the second half of the video. That's getting components made. I'm not going to use either of these features because I just like to have a lot more control over the process. So once again, this may not be the best way to do it. This may not be the most efficient, but it's the way that has worked really well for me, and it allows for a lot of control through the whole process. The way that I usually like to go about it is by creating a spreadsheet like this and naming it something like blip PCB parts list April 2019. So once again, we're putting the date in there, and then we'll say something like item in this column. We'll do the quantity on the board, multiplier, multiplied, and you can put like a column about cost or something like that too. So let's say I'll move this down right here. Let's say processor. So you'll have an item that just represents the processor on this board. We need one of these processors, but let's say that we're actually making 5 boards because in the previous part of this video, we selected 5 boards in the PCBWay cart. But what we do is each part of the multiplied column, we'd say equals, open parens, this column times 5, and that's our multiplier basically. And if you wanted to do this even more flexibly, you could put something like number of boards, and then a little semicolon or something like that. We'll put 5 right here, so we're going to always make 5 boards. And the multiplier, instead of saying B2 times 5, you say B2 times this column. And as you add more parts, you can start to get more useful information, like your total part count, and we'll do a little equals sum, and we'll do the whole column for C. And there we go. So that's our total part count so far. We have 5 processors and 20 things, but this is going to be really useful later on when we actually start to make the cart on DigiKey or Mouser or Octopart, whatever PCB component supplier you use. So while you're populating a spreadsheet like this, you could go around and you could obviously just scroll around and look for the different components and count them up on your hand or a piece of paper, but for obvious reasons, this is prone to a ton of error. So a better way to usually do this is to go into Tools in Eagle and Statistics. And using this Statistics tool, you can actually generate a lot of the information that you would need on this spreadsheet. This is just a different way that you could do it. There's, again, lots of ways that you can approach this. But we don't have to do any of these things today because the parts list, the BOM, all of this, whatever you want to call it, is already available for patrons and actually has been for several months now. That's the Blip Blop Parts List PDF right here. So if you're interested in that, there's a link in the description down below to the Patreon account. Of course, there's no requirement to support BPS on Patreon, and if that's not your type of thing, no worries. We'll go through how to search for parts like this on a website like DigiKey. We'll open up a new tab here and we'll type in DigiKey and head over there. So let's first search for some resistors. I know that for the Blip board, we need 5 470 ohm axial resistors. So the way we'll get started here is I will type in RES into the search bar here. Usually for component suppliers or things like this, they'll just use res to designate that it's a resistor. It's a little bit shorter, a little bit more efficient, and you'll see we have a couple of different types of resistors here. We have surface mount, through-hole resistors, chassis mount, a couple of different arrays of resistors. You could do that, of course. We're going to click through-hole mount because, once again, this is the Blip board, which doesn't have surface mount components. If you were searching for the Blop board, you would search for surface mount chips. So we'll do through-hole here, and we'll look at all of the different options that they have for customizing what type of parts you want, all the tolerances, things like that. Each one of these boxes represents little filters that we can put on our search. So if I scroll down here, you'll see we have tons of options for resistors. I mean, certainly more than I need. And if we look up here under results, 360,000 resistors. DigiKey, maybe chill, dude. But we can narrow down our search a little bit. We have our manufacturers here of all the different resistors. We have packaging, the series, the part status. For instance, if you were designing something that needed to be available for a long time to customers, or you wanted to produce it for a long time, you'd probably want to click active. Or if you're just looking for really cheap parts, sometimes you can click Not for New Designs. You have your resistance, that's pretty important. So how resistive is the resistor? Tolerances, these are things like how close to 2.2 ohms, for example, or do you need your resistor to be? Do you need it to be within 0.001%, or are you cool, having it just a little bit further from that? Of course, you have your power, your composition of the resistor, that's what it's made of, and you can click More Filters and get a lot more options for how big it is, the supplier package, all of these different items. So we can use these boxes to narrow down our search. So let's do that. The first thing I know is that we need a 470 ohm resistor. So I'm going to scroll down until I find, here we go, 100, 200. You can search for this more easily, but I'm just bad at internet. Here we go, 470 ohm resistors. So if you look up here, we now have 1,255 remaining. That's a lot better than 300,000. I don't care too much about the power of these resistors or the wattage really. The composition, that doesn't bother me either. Temperature, operating temperature, that's mostly fine. Most of these are gonna be fine. We know that it needs to be axial. That's important for us too. These are resistors that basically have leads on either end. That's what's spec'd for our PCB. The supplier device package, I don't really care about that either. Let's go ahead and apply these filters and see what comes up. So now we have our narrowed down parts list here. What you'll notice here is that just like at the top of the page, there are tons of options down here. This is going to be the same for most part supplier places. So DigiKey is just one of them, but Mouser will do this too, and a couple other places that you can buy components from. So if we look here, we can see the manufacturer part number, who's actually manufacturing it. We've got the quantity that they have available, which once again, DigiKey has 310,000 of these resistors available. That's kind of a lot. It's more than we need for sure. The tolerance, all of these different things, as you scroll to the right, you can just sort of prioritize based on what you want. Now, if you're looking closely, you'll see that most of these parts actually have duplicates listed right below them or above them. And this is maybe confusing at first glance, but there's a good reason for it. So DigiKey and Mouser and all of these wholesale suppliers are just that, they're wholesale suppliers. So they specialize in providing bulk components to larger companies. And you'll see that in the minimum quantity here, so this resistor right here can be ordered basically in a massive amount with a minimum quantity of 5,000, but for super, super cheap, about 1/2 cent per resistor, or you can buy just one at a time for a full 10 cents per resistor. I mean, these are cheap either way, but if you're buying in bulk, you can save a lot of money. Anyway, we're gonna go ahead and click on this resistor right here. Down here, you'll find even more specific information about the resistor. So right here, we've got our data sheet. This is a document provided by the manufacturer. That's gonna give us like just a crazy amount of specifics on the characterization of this component. So look, we have our single pulse power. We've got all of these different plots for basically how fast you can pulse electricity through it. It's fascinating if you're a geek like me, but this looks good to me, so I'm gonna add this to our cart. And we need 5 of these resistors per board, so we're going to have 25 total. Boom, enter, add to cart, and there we go. So now we've got a resistor in our cart. Look, our board is only gonna be 73 cents. It's obviously not true. Let's add a couple more components here. We need some capacitors for this board too, so I'll do a general search for CAP cap. And once again, we're gonna be met with this big list of options for what type of capacitors we want. So for our purposes with this model rocketry board, it doesn't really matter too much what capacitor type we use. You could use electrolytic, ceramic, tantalum. I actually haven't heard of that one before. Film capacitors, it doesn't matter. I mention this though because there are some considerations, especially if you're doing things that are actually going into a 0G or rather vacuum environment, electrolytic capacitors won't work so well. Anyway, just to get that out of the way, we'll click on electrolytic because that's just the kind I want to use today. And we'll start doing this narrowing down just like we did for the resistors. Once again, I'm going to click on the More Filters tab and I'm going to make sure that these are through-hole mount capacitors because these are for the blip board. The blop board, you would want surface mount. But for blip, we're going to click through-hole right here, apply filters, and it's going to narrow a bunch of things down for us. Now this 1 UF capacitor is going to be on the 5-volt rail just around where the voltage regulator is. It's going to help stabilize some of the output from that regulator, which means it has to be rated for at least 5 volts. And just to give us a little bit of leeway here, I'm actually going to click capacitors that are rated for 7 volts and higher. And I'm going to scroll all the way down to 600, and then I'm going to hit apply filters. We also, of course, need to select the capacitance for the capacitor, and that is going to be the 1 UF or 1 microfarad. So I'll click the 1 UF right here, and I'll apply the filters again. And it's gonna narrow down our results from like 80,000 to 900. This is really getting to where we wanna be now. So looking at these other things that we can narrow down, once again, I don't care too much who manufactures it or what the packaging is, what the series is. The part status, I'm not super concerned about it. It looks like we've probably got a good set of constraints here. And I'll go ahead and scroll down. So once again, we've got these minimum quantities. Some people order 2,000 capacitors at a time. We don't need to do that. I'm gonna go ahead and click on this one. Oh wait, there's one other thing we have to do, and it's the lead spacing. The lead spacing we want is 2.5 millimeters, or I suppose 2.54 should be fine as well. But I'll apply those filters. This is just to conform with how the PCB is set up. And now all of these capacitors should be able to work for us. So I'm gonna go ahead and click on, like this one right here. What you'll notice is that this one is actually not recommended for new design. So I'm gonna go back here and I'm gonna change my constraints because I would like it to be something that's available for a while. I'll click active under part status, apply filters. We're down to 179 options. So this is great. These are really what we want. Let's click on this one right here. This one looks pretty good to me. We've got a 1 UF capacitor with a 20% tolerance. It's rated up to 100 volts, which is considerably more than we need, but that will be fine. So we need one of those per board. We're making 5 boards. I'll hit 5 under quantity right here and add to cart. So this is the basic process that I like to use to purchase parts on either DigiKey or Mouser or any one of these parts suppliers. You don't have to do it this way. This isn't like the end-all be-all solution, but it's worked for me for a little while. So once you've populated the cart full of parts, you're ready to check out. So we'll go ahead and do that now. Let me just pull out my credit card in front of this high-definition camera. Hey, real quick, this is Joe from the future. I'm editing this video right now, and I'm realizing that I left out a couple of key parts, and the first one is cost. So if you're building these boards yourself, how much should you expect to spend? I dropped a couple $100 total for all 10 boards. That's 5 of the blip boards, 5 of the blop boards. And this is gonna be a little bit different depending on where you live, depending on shipping, depending on what board manufacturer you use, all of these different things. But just to give you a sense for what I spent per board for blip, I spent $73.47. So that's manufacturing 5 boards total. I spent $73.47. And the same for the blop board, I spent $63.33. So the blop board is a little bit cheaper, but once again, it's gonna be harder. If you don't have the SMD soldering skills, it's gonna be harder to build. Although it will be a little smaller and a little bit lighter too. So there are basically trade-offs per board. The blip board, all told, took about an afternoon to put together. I haven't done the blop board yet, but the blip board is working great. It's in a little bit of a party mode here. But yeah, so it's working great, and that's all from Future Joe. Thanks a bunch. Back to you, Past Joe. Sorry, a little bit of technical difficulties there. But our parts have been ordered, the PCBs are on the way, and in the next episode of Landing Model Rockets, we're gonna cover how you go through soldering all of these parts onto the board, whether you're doing SMD soldering. We'll be building both the blip and the blop board to show how you go through that process. So if you're interested in the files to actually make these yourself, those are of course available in the Patreon link down below. It's also a connection to a Discord server, there's weekly updates, there's all sorts of cool things on there. And of course, if Patreon isn't your thing, or if you're not interested in that, no worries at all, there's no requirement for it. I'm gonna keep making these videos no matter what, so I'm just happy to have people join me along the way. Anyway, thank you very much for watching. My name is Joe Barnard. May your skies be blue and your wind be low.